Thank you so much for you. Good afternoon, everybody. First of all, I would like to thank you for attending my presentation, and thank you for presenting myself. Today, I would like to talk about this topic, as she said, why it is a plastic. As you know, a plastic demands and growing continuously over the world with the increasing the number of population. And we are using especially the polycarbonate in aerospace, in the plane, in auto, it is demand in many industrial plant. In my agenda, I will highlight it for different topics, experimentations. Experimentation, I will also highlight for the effect of processing parameters, rheology, validity of Cox smears, and conversion of viscosity. And the last topic, the particle size distribution. In my topic also, I will concentrate how to produce the color. To produce the color from first time, it is really very interesting and very complicated. Why? When you are extruded the material all together and with different formulation, additives, pigment, it is complicated to get the color from first time. And it caused to waste billions of dollars over the world for this reason. Actually, I published around 36 papers. I used different methodology in order to reduce this rejection. Today, I will talk about rheology, dispersion at different processing parameters. In order to study the color system, how everybody I see, for example, the apple, it looks red color. He believes his eyes seeing. Actually, it is a method of three factors in order to see the color. It is the light, hit the object, then it reflected to your eyes, then interrupted in your brain in order to see color. So basically, there is formula, it's DE, it is the root of under square of delta E, A, L, and B. So if you get DE less 0.85, it means you get the good color. Wow. From this photo, can you see when the light is hitting the object, there is in the plastic, the pigment. You can see it for sure. You can see only by microscopic or SEM. When the light is hitting the pigment, it could be reflected, it could be speculated. So the incident light hit the pigment and reflected to your eyes, then interrupted in your brain in order to see the color. What is the possible reason for color mismatch? It could be incorrect formulation when you are preparing the pigment, additives, chemicals, polymer. It could be the interaction of a processing parameter. It could be the poor pigment dispersion. Dispersion is very important topic we will highlight there. So what is our research objective? First of all, to improve the probability of first pass of the color. Optimize the effect of a processing parameter. When you are extruding the material, you have feed rate, you have speed of the screw, you have the temperature. This is the processing parameter. Any variation or switch of any parameter, it could change the color. Effect of rheology. I published many papers in rheology, and I correlated also with the color. Rheology, it is the flow of the material. Every material like mayonnaise, oil, everything, every material have different rheology. Identify the optimum of complex viscosity at 230. So I did all this research at 230, and after that, the study of formulation dictated sample without pigment and with pigment. So I prepared 2 samples in order to see the effect of the blending at different formulation with pigment and without pigment. The material I prepared, 2 polycarbonate with different melt-flow index. So mix it together to see how it affects the viscosity, and the 3 additives and 4 pigments. And after that, the material extruded, put it in molding machine to design rectangular shapes in order to take more run under experimentation by rheometer or dispersion by microscope. So in our plan, actually, we will carry the rheological experimentation and analyze the processing data. We run all the experimentation by 2 extruder, one in SABIC, it is in Canada, Toronto. It's called Coburion extruder. And I use another extruder in University of Toronto. It's called Minilab. It is a small extruder. You can run a small sample in order not waste wastage material, in case if you fail. After that, I correlate all the result of a processing parameter, rheology, dispersion, to get final result from this investigation, and in order to understand any issues or factor that bearing the effect of variation of the color. The machine which I use the extruder, Coburion, the molding machine, the rheometer, and that's the last one is the Minilab extruder. It is very expensive, by the way. And this is the spectrophotometer, the sample after the experiment. I can check it by this instrument to see the value of DE in order to evaluate the color. The second stage of my experimentation, the same material of polycarbonate, polycarbonate 1 and polycarbonate 2, I run it with 11 step variated. For example, from 0 to 100, the first polycarbonate, second one 20, 80, 11 steps. So all these formulation, I run it under microscope, run it under the rheometer to get the result for each step in order to check the probability of mixing and the variation of the polycarbonate, and finally to see the effect of variation in viscosity, because viscosity is the more important factor in studying the color change. I get the sample, from the same formulation, 70% of polycarbonate 1 and 2. This shape, I put it in under effect of a processing of temperature to see the variation of color. So the vertical line is DE, and this is the temperature. So at 230, you can see the value of the color is little, almost around 1 or less, still acceptable. But we notice after increasing the temperature from 230 to 255 till 280, almost constant. So this is significant value. We can concentrate it in order to fix the color variation. Also, the same sample, I designed it like a 25 millimeter diameter to run it under the rheometer in order to study the viscosity. Before doing or running rheological experimentation, the same sample, it runs under dynamic strain sweep to see where is the viscoelastic region and to see the effect of the shearing after increasing the strain. So if getting shear thinning, it means the experimentation running in the right way. Also, Cox-Mears rule, you run in 2 techniques, dynamic frequency sweep and strain sweep. So I find the both result of the viscosity almost coincide or identical. When they both are identical, it means it is meeting with the application of the Koch-Mears rules. So, and when you can notice, when you are increasing the frequency, you start getting shear thinning, and the viscosity is decreased, especially after 10 hertz. Also, the 11th step, where I run it in the second extruder, which I call it SP, the 11th step, each step, I run it under rheometer. The first diagram shown to you with pigment, and the second one without pigment, to see the variation. We have noticed when we are increasing the frequency, it gets shear thinning and viscosity decrease in both cases, but more decreasing in viscosity when we adding pigment. Pigment additives decreasing the viscosity. One more thing, we have noticed in the two cases, both of them not follow the Koch-Mears, not 100%. It could be experimental error, or sometimes the dispersion or the mixing is not perfect 100%, but generally it is acceptable. Koch-Mears, we run it for one machine. Now we run the Koch-Mears for the two machines, Coborian twin extruder and the Minilab extruder. For each extruder, we run it as dynamic frequency sweep and as strain sweep. You see in the first extruder, it is identical or consigned. The second extruder as well. So basically, it is applicable with the Koch-Mears for both instruments. And the more important or influential variation for the factor of viscosity, we can notice the content formulation. You know, polycarbonate with different multi-flow index, when you mix it together with different content, it affects the viscosity. This is very important. Number two, effect of processing. From the previous curve, we have noticed when we are increasing the temperature, the color is affected and the viscosity as well. Configuration design, it means is connected or related with these results in order to design the screw for to get the proper color. From the second diagram, as you see, I get the same material and run it under the rheometer to see the viscosity for each extruder. We find it, the red color, it is for Coborian machine, and the second one for Minilab. The viscosity it's showing is higher in Coborian machine. When the viscosity is higher, it means not is much higher, you know, it is slightly higher. When we run it under effect of the processing parameter, it can protect or prevent any degradation in the material or in the color. So Coborian machine, later on, we discover it is much better, almost done. So the same steps or variation of content, we run it under dispersion. The same material, I put it the sample under microscope by histogram, I get the data, I draw it, and it's showing to me also it is not following the dispersion distribution for both. Then I get another sample from the highest reading and lowest and in the middle in order to see the effect of the dispersion. You can see, for example, at number 2, it is the average diameter. It is like 2 micron of the pigment, and the number of particles, the highest is the blue one. It means, you know, when we get it, the percent of content of the polycarbonate is 0 to 100, it's showing the highest number of particles. So basically, you know, we concluded when we are run the experimentation under 230 and we run rheology, we find with pigment the dispersion getting better, and the difference between comparing with pigment and without pigment, around the 20% decrease in viscosity with pigment because the additives is affected. And we noticed that any minute variation in the content of any running material, especially polycarbonate 1 or polycarbonate 2, it could variate also the viscosity. We notice also increasing temperature, it also improves the color. The average particle size is around 1 to 3 micron, and the number of particles around 55 to 70%. And we notice also the validated of Koch-Mears rule for particle size distribution and for the rheology. And the mixing process are promote and bearing for the color variation. And finally, in order to get a proper design of a screw machine, this study of rheology dispersion, it could be a significant effect for rheological characterization of compound and in order to get the final color. Thank you very much for listening. And anybody have a question, I am ready to go.